The screens that defined computing for 50 years are disappearing. We are entering the age of spatial computing, a fundamental shift from 2 dimensions to 3. This is not simple virtual or augmented reality. SC is the operational paradigm that allows us to conduct complex tasks seamlessly within the real space around us. This revolution relies on a core technical triad: LiDAR for precise distance mapping, and SLAM, which constantly maps the environment while tracking your exact position. The SLAM architecture is critical. It uses a back-end loop to constantly correct cumulative errors, ensuring auditable, real-world state estimation. Beyond SLAM, technologies like Gaussian splats and NeRFs enable rapid 3D scene reconstruction, while generative AI transforms 2D images into rich 3D animations. The theoretical need was defined in 2003 by Simon Greenwald, who argued traditional interaction was inefficient and unnatural. Hardware finally caught up 2 decades later. This technical foundation is why the market is surging at over 20% CAGR, with global forecasts approaching $1 trillion by 2034. The global market is surging, driven by high-cost enterprise solutions in North America, which currently holds the largest share for R&D and commercialization. However, the Asia-Pacific region is the fastest-growing market, utilizing high smartphone penetration for mass-market mobile AR experiences. Look at personalized healthcare. Surgeons use AR overlays, guiding complex procedures with 3D anatomical models, minimizing the risk of errors and improving outcomes. In engineering and construction, immersive 3D walkthroughs prevent costly construction flaws, turning SC into essential risk management infrastructure. But this operational power generates a severe governance crisis. SC devices capture persistent, highly granular data from the environment and third parties. This constant, ambient mapping means SC inherently captures sensitive categories like biometric and health data, essential for personalization and guidance. This reliance on continuous maximal data capture fundamentally conflicts with traditional privacy principles like data minimization, creating a central ethical challenge. While some devices signal recording status, the challenge remains: how do we gain meaningful consent from third parties in spontaneous public interactions? The digital twin framework introduces systemic security risks. As these systems become hierarchical and interconnected, security vulnerabilities scale dramatically. The lack of traceable data provenance in these large, interconnected digital twins compromises the integrity of critical historical records and operational safety. The ability to create functionally perfect digital twins shifts a philosophical debate into imminent reality. This leads us to the most trending metaphysical topic of our time. Spatial computing is the precursor technology to the simulation hypothesis. The SLAM LiDAR stack is the exact engineering blueprint to construct a persistent, conscious simulated world. The SC technology stack, utilizing NeRFs and generative AI, provides the specific blueprint needed to build a complex, persistent, and interactive simulated reality at macro scale. The transition from simulating a single hospital, a current application, to simulating an entire planet is purely a challenge of computational scale, not technological novelty. The methodology is proven. When our digital overlay dictates physical safety, the boundary between the real and the simulated dissolves. Simulation achieves functional equivalence with base reality. The ethical hurdles we face today managing surveillance and securing consent are the very constraints that must define any civilization running a simulated world. Spatial computing ensures that the question of whether we live in a simulation is no longer relegated to philosophy departments. It is a question for engineers and policymakers. As we become masters of creating functionally perfect realities, we are compelled to ask, What evidence do we have that we ourselves are not already computed?